Hello friends. Welcome to the Academy. Let's continue the TS NPTCL AE paper solutions. In my previous video, I only covered the questions from the zero, question number question number 1 to 40. In this video, I'm going to cover the 40 to question number 80 of technical AE paper. So let's start the video here. The first question here is it is from the utilization of electrical energy, that's a traction. The speed time curve for an electric train is shown in the figure. In this segment AB represents. So the examiner given this diagram here and they are asked to find this what is the curve AB represent, segment AB represent this part what it's going to be represent here. Okay, so it's the speed time curve characteristics. We know that we have acceleration, coasting, braking, regeneration, everything parts there. It depends upon the urban or suburban services here. Okay, now here from 0 to A it represents acceleration, from A to B it represents coasting, and from B to C it's going to be braking here. Okay, now as per the given segment AB represents it's a coasting here. So coasting. Next one. The figure shows a thyristor like this controlling power in a load resistance RL. The supply voltage is at 240 volts. This is the 240 volts DC supply they given, and the limit for di by dt for SCR is di by limit is 50 amperes per microsecond. The minimum value of L used for di by dt production here. So assuming that the inductor is here ideal one. Now here, what will be the voltage across the inductor here? So VL. When the ACR is in conduction here, okay, the entire voltage will be appearing across this inductive load and resistive load here. Okay, so when there is no current flow here, then the entire voltage will appear across these two values. Okay, now assuming that here the voltage VL is nothing but VS here. Okay, so VL is equal to VS, assuming that, and this will be equal to L into di by dt here. The entire voltage is appearing across this inductor here. So 240 is equal to L into di by dt is already given it as 50 amperes per microsecond here. Now L will be equal to 240 divided by 50. Okay, so microseconds per ampere, and V is equal to voltage. So its equivalent value will be what? Its equivalent value will be 4.8 and micro Henry. So answer is D here. Next question here. A thyroid type lighting arrestor. So thyroid type lighting arrestor, what you do is, so whenever the lighting falls on the transmission line, there is a device called lightning arrestor here, like this. Okay. Now from this line, we are connected to the some equipment such as a transformer or any equipment that belongs to power system here. So what the lighting arrestor will do is it will take the surge and it will allow low resistance path to the ground here like this, and it will allow normal power frequency signals to the power system here. Okay, that means it offers low resistance path to the surge currents here. So answer D is the right answer for this question here. Next one, unit commitment is a procedure in which. So unit commitment is a procedure in which optimal combination of units in a system is chosen at any given time. That means especially suppose if you are having a two or more thermal power plants and of different ratings, then at the station level they will choose a different combinations of the generators or thermal power plants so that economically power is generated. Okay, economically power is distributed. That means optimal combination means the better choice of the combinations of the units in a system is chosen at any given time. That means they are going to select a different power generating stations or power generating plants so that it will meet the load demand at low cost as possible. Okay, that's nothing but the unit commitment is a processor in which optimal combination of units in a system is chosen at any given time here. Next one, for a single phase full bridge inverter, okay, full bridge inverter Vs is 200 volts DC and the T is 1 millisecond feeding a resistive load. The fundamental component of the load voltage RMS value is, okay, so the basic formula you know that V naught is equal to sigma n is equal to 1 3 5 to infinity 4 Vs by n pi into sine n omega t. So this is a formula for the output voltage of a full bridge inverter. Among them, this 4 Vs by n pi represents its a maximum value Vm. Okay. Now the given question is asking about the fundamental component of load voltage RMS value. So V naught RMS is equal to Vm by root 2. This is a basic equation you know. What is the Vm value? This 4 Vs divided by fundamental means n is equal to 1. Here will be pi. So 4 Vs by pi. Okay. Into. So this is the RMS value means root 2 here. Now this will be equal to 4. What is the Vs value? It is nothing but 220 divided by root 2 into pi. So if you are simplifying this and numerically it is going to be equal to 198 volts. Okay, so 142 into root 2 will matches this answer here. So D will be the correct answer for this question here. Okay. Next question here. It is the range of K for which system with the following characteristic equation is stable. So here they mentioned the keyword as a stable is here. Okay. So let me draw the truth R is stable for this equation characteristic equation here. Okay. So let me take a fresh page here. Now here I am going to take the equation here. What is the equation they given? It is simply, so equation here it is, that is s cube plus 3s square, sorry, let me ks square here. So I'll write down here again. So better I'll copy paste here. Okay, without so let me take this. So let me take the equation here. I'll copy it and here I will paste it here. Okay, fine. Now this is the equation here. Now if we write the R is table column for this equation, R is table, then s cube, s square, s power 1 and s power 0, right? Okay, like this. S power 3 means 1 and here we have k plus 2 and here we have k and here we have 3. Okay, if I cross multiply, let me x here. So what is the x value? X is nothing but k into k plus 2 minus 3 divided by k. So for the system to be stable, we know that x value should be greater than 0. Okay, so simplify this. K square plus 2k minus 3 is equal to 0. So this can be written as, so k minus 1 into k plus 3 is equal to 0 here. So from this, what you can predict is k value. So k value should be, one value should be k equal to 1, another value should be k equal to minus 3. Okay, these are the two possible options. But for the system to be stable, the k value should be, so k value should be positive. So k value should be positive here. So among them, so k should be equal to 1 or k should be greater than 1. So this is a possible option that we are having. So as per this concept, the k value should be greater than 1 or k equal to 1. Okay, so there is a option is a correct. So among them B will be the right answer for this question here. Okay, so let's take the another question here. In a star connected, let me take this question also in the next page so that I can explain there. Okay, I'll paste it here. Okay, see here. So this is a question that is asked there. Now here, in a star delta connected transformer, three-phase transformer, the supplied voltage is. So let me take this first of all star connection here. So here we have a star connection like this, and here we have next we have a delta connection like this. Okay, now a star is their input, output is delta, three-phase transformer supplied with 11 kV. Okay, so they mention it as 11 kV is the voltage between the two phases. It's a line voltage they represented on the stator star side. The line current is 20 amperes. So this will be 20 amperes given the data. Per phase turns. That means the ratio of N1 is to N2 will be N1 by N2 will be what? It is going to 11. The given. The secondary line voltage and the currents are. So here secondary line voltage. What will be the line voltage here? That is a VL and line current. So what will be the current here? IL current. Okay. So these two values we want. We know that whenever the given question like this, think about this phase. That means V phase 1 divided by V phase 2 or V phase 2, which is equal to N1 by N2. But in the given case, the line voltage is specified. What is a VP1? Is nothing but V line voltage divided by root 3. Okay, so that is equal to 11 kV divided by root 3 here. So from this, what is a V phase 2 or VP2? So VP2 is equal to VP1 into N2 by N1. Okay, so what is VP1 is nothing but 11 into 10 power 3 divided by N2 by N1 means 11. Okay, but here we have root 3. Okay, root 3. So simply 1000 divided by root 3 will give you the 1 point. Let me check here. Yes, so it's going to be 57.7 volts. 57.7. So it is going to be 577 volts here. So 577 volts. Among the option, you can directly pick the answer as A. Now I'll give the explanation for the currents also. Now here the line current and phase currents both are equal only. Okay. Here the line current is different and phase current is different. So I'll talk about. Let me take the currents here. I2 is nothing but the current in the delta winding. So I2 phase divided by I1 phase is equal to, it is nothing but N1 by N2. So from this, what is I2 phase is nothing but, so I1 phase current into 11. Okay, it's nothing but 20 amperes into 11 will be the answer here. Now what about the I2 line current? I2 line current is nothing but it's a root 3 times that of 20 into 11. So which is equal to 381 amperes. So answer will be A is the correct option for this question here. So let's move to the next question here. We covered these two questions here. Okay, so answer for this question will be 577, 381 amperes. And the next question, 48 question here. A short circuit test on single phase 4 kVA 20 by 400 volts 50 Hz transformer gave in the following results on HV side. The short circuit voltage is 15 volts, short circuit current is 10 amperes, short circuit power is 80 watts. The percentage regulation on full load unity power factor. So the given hint as a full load unity power factor means, so full load unity power factor, the percentage regulation is nothing but the percentage impedance. So percentage regulation is nothing but percentage impedance here. which is equal to percentage R, that is equal to WSC divided by, okay, so there's a kVA rating here. That is WSC is nothing but the short circuit watts. So it is 80 watts divided by the kVA rating is a 4 into 10 power 3. Okay, so into percentage means we'll talk about the 100. Okay, so 100, 10 0 gets cancelled. So 8 by 4 means is nothing but 2. So answer will be 2 here. Next one, consider the following statements. Which of these statements are correct? Okay, the reactance relays are preferred for ground fault relaying, there is a line to ground fault. Impedance relays are most suitable for protecting long transmission lines. More relays are best suited for protection of long transmission lines. Reactance relays are widely used for the protection of medium transmission lines. We know that reactance relays are used for the protection of short transmission lines. For a medium transmission line, more relays are used. For long transmission lines are for long transmission, more relays. For a medium transmission line, impedance relays are used. Okay, so among them, which is the correct option? So correct option is the reactance relays are preferred for the ground relaying faults. Impedance relays are not used. For long transmission line, more relays you are going to use. So 3 will be the option, correct option. Okay. So answer is 1 and 3 are correct. So answer B is the right option for this question here. Okay. Now next one. Consider the two columns A and B. In the column A, different instruments are given. In the column B, certain characteristics of the meter are given. Match A and B here. So they given moving iron instruments, PMMC instrument, and energy instrument here. So you need to match it. On B, no control springs, air damping, electromagnetic damping, and eddy current damping. So as you know that the PMMC instruments uses eddy current damping here. Okay, so PMMC instruments is uses this eddy current damping, and moving iron instruments, yes, moving iron instruments is using air damping here. Okay, air friction damping will be called, and energy meter is having no controlling springs here. So based on this, the option will be D is the right option. Okay, next one. The double cage induction motor has better starting and running characteristics because two of the following conditions. So remember here, the starting condition should have the characteristics such as resistance should be high, okay, inductance or reactance to be low value. But the running characteristics of the machine is such a way that the resistance should be low so that the I square R losses will be less here, and similarly the reactance should be more here so that the machine is going to be convert the energy efficiently. So depends upon this, the inner cage is nothing but the inner cage which is used for the starting purpose. So starting purpose, inner cage is nothing but inner cage is used for starting. So as you know that the starting will have resistance should be high, reactance should be low. So outer cage winding is used for running condition. So as a running condition, resistance should be less, reactance should be more. So which option is going to be match the answer here? So as you can see here, the C will be the right answer here. So C. What is option 2? The inner cage. The inner cage should have low resistance. Okay friends, let me correct here. So there is a small correction here. So inner cage, outer cage is starting for starting purpose, and inner cage for running purpose, friends. Okay, so outer cage for starting purpose. So outer cage having the low resistance, the outer cage winding should have the outer cage winding starting purpose. So it will have high resistance, low reactance. I will repeat it here. The outer cage is used for starting purpose. The starting means resistance should be high, reactance should be low. The inner cage is for running purpose. where the resistance low, reactance should be high. So the inner cage has low resistance and high reactance, and outer cage will have high resistance, low reactance. So option 2 and 3 are the correct one. So option 2 and 3. So please make a correction here. Please make a correction of this point here, that inner cage is used for running purpose, outer cage for starting purpose. Outer cage for starting purpose here. Okay. Please make a correction of this. Next one, the Laplace transform of the function is shown in the figure here. So in the figure they given a step function, and which is starting from the t is equal to 1 to t is equal to 2 seconds there. Okay. So for that we need to find the what is the Laplace transformation of the output here. Okay. Now functional, right, f of t is equal to the magnitude is 10 u of t minus 1 minus u of t minus 2. Okay, if I found the Laplace transformation is equal to 10 by, okay, so 10 I'll take it 10 u of t minus means e power minus 1 divided by s 1 into s minus e power minus 2 into s divided by s here. Okay, if we simplify this one, 10 by s into e power minus s minus e power minus 2s. So answer is nothing but 10 by s e power minus s minus e power minus 2s. So C will be the right answer here. Next one. Okay, next question here. A 5 kilowatt 220 volts 1500 rpm DC shunt motor runs at 1550 rpm on no load with the full voltage applied. If the voltage is reduced to 165 volts, the speed at which it will run in rpm. Okay, so neglecting armature resistance. So N is proportional to EB by 5 here. Okay, now EB is proportional. If we neglect the armature resistance, I will say that V by 5 only. Okay, as the voltage is reduced to 165 volts, the flux is also proportionally reduces. Okay, so that means the both the parameters will be made constant, so the speed will be 1550 only. Okay, so in order to speed will be constant. So one more thing, remember here, DC shunt motor, if you see in the characteristics here, they are almost linear, they are almost maintain same value. Okay, so that from that point it will be 1550 only. Okay, so from this you can observe here. Okay, so next one, a synchronous generator, if the excitation is increased from the low value to normal value with a fixed load, then what will happen here? So this is the question that is asked from the synchronous machines from the V and inverted V curves here. Okay, so you know the diagram of the V and inverted V curves. So see here, in V and inverted V curves, there are three things. First one is excitation here. So we have under excitation, normal excitation, over excitation, and here we have the two curves. The first curve will represent current, second curve will be power factor. So this will be power factor and this will be current here. Okay, so as you can see here, if the excitation increases from low value to normal value, so low value to normal value, of a synchronous generator means first it will act as a leading power factor, later will be lagging power factor. Now, so low value to normal value means the armature current, what will happening? Armature current will decreases, and the power factor is leading. So see here, this is the decreasing here. No, the same option will be given as the power factor will improve and the power factor is leading. They can also say it. So answer is D here. So D is the right answer for this question here. Now, next one, the circuit shown employs two choppers to supply load. Okay, this chopper drive is, see, observe here, the chopper 1 and chopper 2 is there, connection like this, and we have a diode, and here we have the switch here. When you study the switch operation, CH1 is conducting and the current flowing through like this will happen. Okay, so positive sequence. Next one, when we operate CH2 and the D2 is activated, means whenever there is change in voltage, that is a voltage is changes plus minus here. Now the current either may flow like this, or the current may flow from like this. So here we have only two options. Okay. So current either it may be same direction. So current polarity. So current polarity remains the same. So I is remains same. The voltage will have two polarities, either plus to minus or minus to plus volts. That means it will operate in only two quadrants. So two quadrants. Okay. Where the voltage will be negative or positive, but current is positive only. Next question here. The speed of separately excited DC motor is controlled by three-phase semi-converter from the three-phase 440 volts supply. The armature resistance is 1 ohm and the motor torque constant of 2 Newton meters per ampere. If the firing angle is 45 degrees, the back EMF generated by the motor for a torque of 50 Newton meters is. So upon solution it has, so V naught is equal to 3 root 6 by pi into V phase into cos alpha, which is equal to 3 root 6 by pi into the voltage is 440 divided by root 3 V phase value into, so 1 by cos 45 means 1 by root 2. So if you simplify this, I get the answer as a 420 volts. So I am getting the answer as 420 volts here. Okay. Next one. A separately excited DC motor is energized from 440 volts 50 Hz three-phase full converter. The input voltage to the motor for a firing angle of 45 degrees is. So here we are using a converter, three-phase full converter. Okay. And what is the output voltage they are asking? So V naught is equal to 3 VML by pi into cos alpha, which is equal to 3 into root 2 into VRMS by pi into cos alpha is 1 by root 2 here. Okay, so which is equal to 420 volts approximately. So answer will be 420 here. Next question. According to the IE rules 1956, the breaking strength of all the conductors of overhead power lines shall be, so they shall be not less than 350 kg. So it's a standard one, not less than 350 kg. Next one. In the following circuit, the switch is closed at t is equal to 0. The total energy lost in the resistor is at 10 ohms is found to be 60 joules. The total energy lost in the resistor R is equal to 10 ohms is found to be 60 joules. If the R value is reduced to 5 ohms, the energy lost in the resistor in the joules would be. That means here, even though you are increasing the resistance value, the current value may increase, but the energy dissipation will be remain same here. So understand the concept here. That is, even though if you change the value of resistance here, okay, so P is equal to I square into R. Okay, current value may changes, but the overall energy dissipation will be remain same. So answer will be A as 60. Next one. In a three-stack variable reluctance stepper motor with a 12 rotor teeth, the angle through which the rotor moves for one pulse excitation is. So the value of rotor angle beta equal to 360 divided by m into NAR. Okay, which is equal to 360 divided by the number of stacks is 3 into the rotor teeth will be 12. So it is simply 10. So answer is 10 here. Next one, the 61st question here. The unit of speed regulation of the governor is hertz per megawatt. So P is the answer. Next one, the fundamental component of single phase full bridge inverter with the output voltage is Vs. Okay. Now fundamental means it is 4 Vs by n pi into sin omega. Just now we have seen this formula here. The same formula is applicable here. Next one, the pyranometer is an instrument to measure. So it is to measure the intensity of direct solar radiation at a normal incidence. So answer will be B here. Next one here, next question. When high rate of rise of recovery voltage are expected in networks consisting of generators, transformers, reactants, and lines and circuit breakers with the shunt capacitance are employed, to ensure the exponential buildup of 50 Hz recovery without the overshoot, the resistance connected is L is the inductance of the line and C is the capacitance of the line. That means in order to avoid the restacking of arc, what will be the resistance you should connect? This is a value, that is R is equal to 0.5 into square root of L by C. So based on this formula, there are a lot of questions are asked in the previous E examinations. Okay, so R will equal to 0.2, or sometimes they can also write as a 1 by 2 square root of L by C. Okay, next question. In a phase lead compensator has the following transfer function. So first of all, convert this transfer function, given transfer function, into its normal form, that is a K into Z plus S. Okay, so divided by Z. Similarly, we'll make a P here. So P plus S. So you'll make 1 by P here. Okay, 1 by P. Now from this, what you can get, K into, so K into P by Z into S plus Z divided by S plus P. Okay, so for the lead compensator, okay, the pole should be nearer to the pole should be away from the origin, and the zero should be nearer to the origin. So here we have 0 and here we have a pole here. Okay, so from this, the Z value should be less than P. So A is the right answer for this question here. Next question. The armature current on a symmetrical three-phase short circuit of a synchronous machine is. So it has a direct Q axis only. It has a D axis current only. Because short circuit current means current will be maximum. That current will be maximum means, okay, from the D axis current only. So current will be less in case of Q axis current. So these two values you can find from the slip test. Okay. Next question. So this question, in the circuit shown, the power in the resistor R is 8 watts. When the Vs1 is equal to 12 volts, Vs2 is equal to 0 volts. Find the power in the same resistor when Vs1 is equal to 12 volts and Vs2 is equal to 24 volts in watts here. Okay. So first what we will do is, let me assume this is a voltage here. Let me assume this one is a V1 and this one will be V2. So from this V1, V2, I will write the node equations. So let me assume the node V1. So V1 minus Vs1. Vs1 only is another 12. So 12 divided by 2 plus V1 by, so R value what we, okay, we need to find. So the given R value is 2 ohms. Okay. So P is equal to I square into R. So P value is given as a 8 is equal to, okay, I square into here what R value. So R is nothing but 2 here. Okay. So simply R is nothing but 2, we can write directly as, so V1 by, directly I can say resistance value 2 plus V1 minus V2 by 1 is equal to 0. So this is the one equation. And similarly, the K that at node V2. So node V2. Okay. So V2 minus this Vs2 value is given 24 given. So 24 divided by 2 plus V2 minus V1 by 1 plus V2 by 2 is equal to 0. So simplify these two values and you are going to find the value of V1 and V2. So from this we want V1 value. So V1 will be what, equal to 8 volts. So V1 will be 8 volts we know. Okay. So or simplify from this also we can find V1 equal to 8 volts. Now what about the power dissipation? The resistance P is equal to I square into R. So I is nothing but I square into R, we can say V square by R here. So V is nothing but what? 8 volts. 8 square by its R value is 2. So which is equal to 64 by 2, 32 watts. So answer will be D here. Next one. So this question is from the utilization of electrical energy, right? A 500 watt bulb fitted with a reflector illuminates an area of 2 meters into 2 meters the area with an average illumination of 500 lux. The efficiency of the reflector is 50%. The efficiency of the bulb in the lumens per watt. Okay, so total illumination. So total luminance total lumen is equal to the illumination E into A by eta here. Okay, so this is equal to, so let's assume the total lumens X into the watts are 500. Okay, is equal to illumination is 500 into area is 2 into 2 divided by eta value is 50% means 50 into, I'll write 100 here. Okay, simply from this X is equal to be 8, that is the lumens per watt is 8 is the answer. The specified variables at any PV bus for a load flow study are, okay, for any PV bus the specified variables at any PV, that is a PV bus for any load flow study. So any load flow study is nothing but real power and a voltage magnitude. So real power and voltage magnitude. For example, it's a load bus means the only specified quantities are P and Q, V and delta are not specified. Okay. Next question. The K map shown the minimizer function is. So see here we can map 4 here. That means for example here A bar, B bar, A bar B, A B, and this will be A B bar. And here we assume CD means C bar, D bar, C bar D, CD, CD bar. So if you are mapping this 4 here, so common point is A, this one will be A, and in this terms 1 means is C plus, so again you can map 4 parts here. Okay, so 1, 2, 3 and 4. So from these common points what you can observe it is it's a B bar and a D bar plus when these two are there, okay, that means A bar, B bar, and here we have C bar. So answer will be C here. The next one, the electrode rod is used for welding, uses a coating on it, okay, to give a vapor to serve as a shielding gas to protect the wheeled arm area, the wheeled area from the atmosphere contamination. Okay, and the next one is to protect the arc, to provide the slag to protect the welded area, to provide better contact with the base material. So our correct options are here. The electrode rod is used for welding, uses a coating on it, because it to give a vapor to serve as a shielding gas to protect the welded area from the atmospheric contamination is one. Okay, and to protect the arc it's the wrong option. To provide slag to the protected welded area, so answer is 3 here. So to provide the better contact with the base material is wrong. Okay, so which of them are the correct statements means 1 and 3 will be the correct statements for this question here. So let me take the next question here. Okay, 72nd question here. A hall with area of 10 meters into 10 meters is to be illuminated with a 240 lux using 30 watts CFL bulbs. The lamp maintenance factor is 0.7, utilization factor is 0.72. The CFL bulb gives 80 lumens per watt. The number of CL bulbs are required here. So the number of formula here is number of CFL bulbs are lamps is equal to, that is A into E, okay, into WLF divided by utilization factor into depreciation factor into lumen. So which is equal to, that is a is the area is nothing but 10 into 10 into they given it as 240 lux. So 240 lux here into 1 divided by, that is a maintenance factor is 0.7, utilization factor is 0.72 into 80 lumens, and how many number of bulbs? 30 bulbs. So 80 into 30. So simplify this, we will get the answer as a 20. Okay, let me take. So 20. Answer will be C here. Next one. In a DC generator, the winding of the interpoles is, say a DC generator that means in series with the armature winding to create a pole of same polarity as the main pole ahead here. Remember here ahead for generator, behind for motor. So ahead in the direction of rotation here. So answer will be C directly I am saying here. Next one. Consider the following statements. Step up cycloconverters requires forced commutation. Step down cycloconverters operates on the line commutation. Okay. Step up or step down converters can be load commutated for any type of load here. So correct statement is it. So step up cycloconverters means what you will do is, if you are giving a supply frequency of, so for example, Fs is equal to 50 Hz supply frequency, the output frequency is more than 50 Hz, means either it may be 100 Hz or it may be 150 like that. Step down means if you are giving 50 Hz, the output frequency will be less than 50 Hz, either maybe 25 Hz, okay, or 12 Hz like this. Okay, 12 Hz. This is because step up cycloconverters requires forced commutation to turn off the ACRs. Okay, so at the turn of the ACR, the ACR is going to be off, so that the supply frequency automatically increases. I mean, the load frequency increases. Step down converters operates on line commutation. Wherever you want to off means will be off, so that it is going to have a less number of frequency compared to supply frequency. So these two will be the correct options. Answer C will be the correct answer for this question here. Next one. A 6-pole 3-phase 50 Hz induction motor has a maximum torque of 10 Newton meter at 875 rpm. The torque at slip 5% is. Okay, so it's a standard direct question. So we'll substitute the formula here. So what is the formula here? Okay, right. So we know that Ns is equal to 120 F by P. So from this, or you can directly guess the Ns value. It will be 875 means nearest value will be 1000. So 1000 rpm. Or you can find the formula Ns is equal to 120 F by P. You will get the value. Now the slip. Okay, Ns minus Nr by Ns here. So what is the Ns? 1000. So 1000 minus 875 divided by 1000 here. So simplify this, you will get it as 0.125. Okay. Now I'll let the formula. So TFL by T maximum is equal to, so 2 SFL into SM divided by SM square plus SFL square. So from this 2 into SFL value will be 0. They given us a 5% slip, 0.05 into 0.125 divided by 0.05 whole square plus 0.125 whole square. So simplifying this, you'll get the answer as 6.9 Newton meter. Answer will be D here. Next question, 76 question here. The function f of s could be a driving point impedance or admittance function of RL or RC network. Okay. The f of s is equal to s plus 1 into s plus 3 divided by s plus 2 into s plus 4. This function can be realized as. So first to draw the pole zero diagram here. Okay. So first one will be here. S is equal to minus 1. This is 0. 0 minus 1. And for here pole minus 2. And there will be another 0 minus 3 and finally it will be 4 minus 4 here. So this type of pole zero diagram will represent that it is a RL function here. Okay, RL function. So from this pole zero diagram itself we can say that it's a RL network if f of s is equal to z of s here. And one more condition here to check the answer is, so z of RL of 0 should be less than Z of RL of infinity. Okay. So when you are substituting R equal to infinity, what will happen here is going to be less than 1. So here 3 by 8 should be less than 1 value here. Okay. So answer is A. Next one, the H parameters of the matrix H parameter matrix of the network shown figure. So V1 and V2 given, they are 1 ohm, 1 ohm, 1 ohm like this. Now simply you can simplify this one. Is V1 is equal to H11 into I1 plus H12 into V2, and similarly I2 is equal to H21 into I1 plus H22 into V2. So this is the network. Now, first either we will take V2 value. So V2 is short circuited. That means V2 is going to be 0. So V1 is 0 means V1 by I1 is equal to H11. That means we are making the short circuit here. This short circuit is over. Now the what is the voltage here? So entire voltage if you find relationship between here. So minus V1 plus I1 into 1 this value, and the current flowing here is this in this resistance will be what? It is nothing but I1 plus I2. So I1 plus this value plus here. So I1 plus I2 into 1 is equal to 0. Or simplify this without simplifying this. What I will do is I will make this y1 and these two will be in parallel. Short circuit means these two will be in parallel. So parallel means it is going to be 0.5 and this will be 1. So simply it is going to be 1.5. So among the options H11 is 1.5 is the answer. So from this you can simplify this as H1 is 1.5. And similarly, when the V2 is made short circuited, next parameter we can found here it is H21 is equal to I2 by I1. Now tell me, where is the I2? I2 is the current flowing here. So I1 is the current flowing here. Okay, so I1 and I2. And we need to find the relationship between this I1 and I2 here. Okay, so by using the current division rule, you can apply the current division rule and you can find the value. It has minus 0.5. Okay, so minus 0.5, and similarly H21 also we get it. Okay, so minus 0.5, and H12 also you can find as 0.5, and H22 is also you can find 0.5. So among the options, they will be the correct options here. You can substitute the values of I1 and I2 for short circuit of V2 and find the values of currents here simply. Okay, so let's move to the next question here. Which of the following is a cold cathode lamp? So mercury vapor lamp, sodium vapor lamp, incandescent lamp, neon lamps. So neon lamps are gas vapor lamps. We can also call it as a gas vapor or gas discharge lamps also we can say. Okay, so these are nothing but lamps. They are having a cold cathode lamps. Okay, so answer is D here. The arc voltage in circuit breaker is, so arc voltage in circuit breaker is such a way that the arc currents also follows it. That means each they are in each phase. They are okay, in phase we can say, or we can say the arc voltage or the in circuit breaker is having a property of resistance here. Okay, that means the in resistance the voltage and current are in phase. So in phase with the arc current. Okay, so answer is A. And what about the power factor? So power factor is unity 1. And last question of this video session here, a second order system with zero initial conditions has an impulse response. When excited by a unit step, the steady state value is going to be. Okay, so first convert this equation into its Laplace transformation. So C of S is equal to, so 10 e power minus 5t into sine 10t. What will you get? So it is sine 10 divided by, so s plus 5 whole square plus 10 square. Okay, now we need to find the final value. Steady state value is final value. Limit s tends to 0, yes, and your input is unit step means it is 1 by s into 10 into 10 divided by s plus 5 whole square plus 10 square. So s gets cancelled. So 100 divided by, so s is 0 means 5 square plus 10 square. So 100 divided by 125, 0.8 will be the correct answer for this question here. I hope you have learned something from this video, and I know that some of the questions are a little bit tricky, but it will take a lot of time to give explanation, proper explanation. So I try to give an the explanation just for the justification of answers here. Okay. So thank you friends. Thanks for watching my video. And for your examination, please share the question paper to my mail ID, that is TEEA for you at the rate of gmail.com for the solutions here. Okay, gmail.com here. So thank you friends. Have a nice day.